Let's talk about grafting now. Grafting is a method of taking stem tissue from two different individual trees, usually of different genetics, and joining those two, and the tissues will grow into each other and it'll become one tree. So you can take a piece of a stem cutting from a fruit tree, is often what it's done with, that produces really good fruit, and graft it onto the lower part or the root stock of a similar species, but with different genetics that might be not produce such good fruit, but have really good adaptations and hardiness in certain kinds of climates or soil. So you get the best of both worlds. You've got a tree that can withstand the soil and do well and resist disease, and on the top produce really good fruit. And grafting has been around for thousands of years, so it's a very old technique. Again, you're taking tissue from one tree that's called the scion, is the top part of the graft, and the bottom part is the stalk or the root stock. So often rootstocks will be grown all in a nursery. We're ordering some rootstocks from a nursery up in Oregon, some apple rootstocks, and they're grown often from the suckers of apple trees, growing off the bottom around the stump of the tree. So they're coming off of the genetics of that root. And those are cut off and then rooted. Sometimes that's done with mound layering, where you can see all of the little sprouts, the suckers coming off of the rootstock, and they mound up soil around them and they form roots, and those are cut off and then sold as rootstock. And then what we'll do is we'll graft on the scion, or the top part of that graft, from an apple crisp. We often do that in this class, but some other type of really nice fruiting apple onto that rootstock. The rootstocks for the apples that we're going to use are often called African M111 is the name of that rootstock cultivar, and that is one that does better with heavier soils without resisting phytophthora root rot in heavier clay soil. So it does well here. And then the top part, again, is just the scion to produce ideal types of fruit. What's the reason for doing grafting? Why even take the time to join the scion wood to the rootstock and go through all that? Well, it's to create a better overall plant or tree. In this case, a better overall fruit tree, where the rootstock, you've incorporated genetics of that rootstock, which are disease resistant and insect resistant. For example, you also could graft so that you're grafting onto a rootstock that incorporates temperature tolerance, so it can handle colder and hotter temperatures without getting diseased or stressed or dying. So that kind of relates to the rootstocks more, but also if you have let's say an orchard of one species, let's say apples, Honeycrisp apples, and Honeycrisp become somehow less favorable, less marketable, you can take all of those off and graft a new desirable cultivar onto that same rootstock. So you can completely change the orchard's what it's producing by grafting. And that is done pretty often, especially when different cultivars of the same fruit become more popular or improved. For example, you could have an almond orchard, and at some point the strain or the cultivar of that almond is less marketable, or it's inferior. It's not as big as they can get. Then you could do a transformation of your orchard by putting all new grafts of almonds onto the almond rootstocks. You can change the cultivar or even the fruit that you're growing in an orchard sometimes. That isn't done too much, but you can change, you can graft between species within the same genus often. The closer they are to each other, the closer the rootstock and the scion are to the same species, the more likely is the graft will take and produce good fruit. But you can sometimes do interspecific grafts, meaning you could have a citrus, let's say you have a lemon tree, and you start grafting on some orange and lime and grapefruit, something like that. As long as they're all in the same genus, they should work. You can also use grafts to control bark damage. Grafts could be, you could form a bridge of bark tissue that you remove from somewhere else and form it from the rootstock onto the scion, so it bypasses that damaged, wounded part. So it could be a form of kind of like a bandage or a a graft, just like people get skin grafts from burns. This would be a bark graft to protect that wound and help it heal. Let's look at some of the details of grafting. In a graft, what you're doing essentially is joining the cambium layer of the rootstock and aligning that up with the cambium of the scion wood, the wood that's going to be put on top and joining the rootstock. So in this image, you're seeing a cleft graft, which means you've got that, you're looking straight down on the rootstock. You've cut off the top part of that rootstock, and you've inserted those little round ones on either side of that wedge. Those are stems of the scion wood that you're putting on top. And you've aligned the cambium, that's the layer of cells that divide constantly underneath the bark. It says rootstock cambium in the image. And you're aligning the cambium of the rootstock with the cambium of the scion. So you can see those two branches have been shoved into that wedge, but they've made sure that those two are on the edge, and the cambiums of those two are touching each other, so they will join together. Since that cambium is dividing and creating new cells, the new cells growing there will connect up with the roots, the new cells in the cambium and the rootstock in the scion, and they form one new cambium. And that's how the graft is able to connect with the food source, the water and nutrient and sugar source, the xylem and the phloem of the rootstock. So it's able to connect, and now it can get water and food and move sap around into the scion wood from the rootstock. So that's the details. You just have to align those two. You wouldn't put those two scion pieces in the center of that cut wedge, because then the cambiums wouldn't be touching, the cambium of the scion wouldn't be touching the cambium of the rootstock. That's why they're on the edge. And you can see there's some cambium on the inner side of those scions, little circles there, that's not touching cambium. That's fine. It'll just wither away, and it's the outer part where the two cambiums are touching that will join together. Here are a few more grafting principles. As I mentioned before, there needs to be taxonomic compatibility between the rootstock and the scion, which means they have to be very closely related. In general, the closer they are to being related to each other, like the same species between the rootstock and the scion, but maybe a different cultivar or strain, then the more success you're going to have with that graft. Although you can graft within, it's possible to get some success when you do different species within the same genus, and sometimes even the same family. The image on the upper right is just a joke. You cannot do bananas and apples. Those are two very different species, and that really wouldn't work. That'd be great. The bottom one is real, though. You can do a number of different types of citrus, all in the same genus, but different species and sometimes different strains, all on the same tree. I'm not a big fan of fruit cocktail trees. I mean, it's a neat thing, to be able to do this, but they tend to be weaker trees and not be very strong and prone to disease. And so if you really want to get a good crop of limes, lemons, oranges, grapefruits, have separate trees. This is just kind of for fun. Again, the fruits usually don't develop as well. You don't get that many, and they're weaker overall. Okay, the timing of the graft is important too. Using dormant scion wood is really important for that graft to take. You need to waterproof the graft junction when you join those two pieces. You have to seal it, and so the water doesn't get in there for a few months, so the cambiums have time to grow together before they rot or get infected. The rootstock diameter is always bigger than the scion diameter, as shown in that previous slide. You have little scions put into the bigger rootstock. Sometimes they can be about the same size, so maybe that should say rootstock diameter greater than or equal to the scion, but for the most part the scion is smaller for the non-whip and tongue grafts. And maintain, and I'll tell you more about what a whip and tongue graft is in just a sec. Maintain orientation, so you do not want to put your scion wood in upside down. That won't work. kind of like with our stem cuttings, you've got to remember which way is up. And that seems obvious, but it isn't always when you start doing hundreds of cuttings and you have you might have your scion wood not be the stem tip, so it's back from the stem and you can't really tell which is the top and which is the bottom, but try to remember that. So this is the most common type of grafting cut called the whip and tongue. So as you can see in the picture, you first make an angled cut in your, on the bottom of the scion and the top of the rootstock, and you make a little notch in both of them. So when you put them together, you're joining the scion and the rootstock. And in this picture, it's different from the last image I showed you, but the scion and the rootstock are the same diameter. So they make this really clean, nice joined point. And the little tongue in there kind of goes into the little wedge in the bottom, the tongue of the rootstock. Excuse me, the tongue of the scion, the top, goes into the wedge of the rootstock, and theoretically they fit very nicely. It doesn't look quite this clean when you do it yourself, and the wedges and the cuts are a little deeper, but they hold on to each other better. And as long as some cambium is touching each other from the top and the bottom, then it should take. And then you can see on the far right, it's sealed with some kind of water-resistant sealant. This is what the whip and tongue graft looks like more in real life, not just an illustration. And you can see it's not a perfect match between the top and the bottom, but there's a lot of contact in this one. This is a really good whip and tongue example. Lots of cambium contact here. Once you seal it up, often we'll put something kind of like first aid tape around that. You can also spray it with a tar sealant and then put the tape around. Sometimes you can even use the green stretchy gardening tape. Anything that'll keep it waterproof for a while. I'm going to talk you through the procedure for this type of graft, the cleft graft. It was similar to it's the same as the one that you saw that image for a few slides ago. So you have your horizontally cut surface for the rootstock, and you place your knife on top of that, going all the way across the diameter of that cut surface, and then gently rock the knife back and forth down as you push the knife down, kind of creating a wedge in that rootstock. The scion wood doesn't have to be the same diameter as the top, but you cut your scion wood and create the tip of it, the bottom part of that scion wood needs to be cut into what's like a screwdriver-like tip. So tapering, it's flat but tapering as it goes down to a point. And that's going to be the part that wedges in to that cleft that you created with the knife on the rootstock. You then insert the scion wood. If it's a lot smaller, you make sure it's near the edge so the cambiums are lining up of the scion and the rootstock. And maybe you put another one in on the other side, depends on the size of it. They can be similar diameters, and then you would only have one put right into the middle. And then you can tape it up, like I said, and you can use we use something like first aid tape. It's called grafting tape. Other ways to do it, and you can even spray the pruning tree sealant onto that, which is kind of like a spray tar, and then cut the scion top off if you need to, right above a bud. It's like a node. It's just kind of like a stem cutting, and that's it. Label it, water it, keep it in a pot for a few months, and shade it and cool, not too much light. It's just in the ICU. It needs a lot of care and just gentle kind of temperate conditions, not too hot, not too cold. And in a couple of months, you might see the buds start to open up, and then you can remove the tape. You try to remove the tape sooner than that, the graft might not have enough connection between the rootstock and the scion, and the scion might fall off or it might break off. So you really want to wait, and then still keep it in the pot for about 6 more months. Well, not 6 months past that, but 6 months total. So if you started, you want to do like 2 or 3 months past the 60 days to even think about putting it in the ground. Often when we do our apple or other fruit tree grafts in this class, we'll do them around early March, and then we tell people don't put it in the ground until after the 4th of July. So you've got at least 4 or 5 months in there. Some more grafting info. Dormant season grafts are the best time to get your scion wood and do the graft. And like I just said, don't remove the tape until the 4th of July or even into August, Memorial Day. The rootstocks that are common in apples and avocados are African rootstocks, but there's many other different types of rootstocks. But these two are really great for our clay soils because those rootstocks are resistant to phytophthora or root rot, which occurs when water sits on the roots for too long, which happens more readily in our soils, which tend to be clayey along coastal California. So they hold on to the water and they can cause rotting. Have you ever noticed when you've seen avocado orchards around, especially around the south coast here, they're usually on sloped land and usually unstable lands. Because gravelly soils are very well drained, and those are the places the avocados do best because the water drains quickly and doesn't sit on the roots. Even if you do have African rootstocks to your avocados, they still need well-drained soil. If those trees are healthy from grafting, you don't have to use as much or any pesticides, which is great to keep, while they're just growing early on. If you're keeping a scion wood, let's say you've done some cuttings and you're not ready to graft them, you can keep them in the fridge for quite a while, for a couple of weeks, and they'll still be viable. This is kind of a counterintuitive point. The higher the graft, the shorter the tree. So you want to have your graft near the bottom of what will be the mature part. When your tree is mature, the graft will be down at the bottom. Think about that. The higher you do the graft up on your rootstock, if you said left 12 to 24 inches tall of rootstock and then grafted the scion on top of that, the rootstock becomes the root system. It doesn't contribute to the crown. So if there's more rootstock, there's less crown, and less growth will happen on the crown. So it's better to have it shorter, that rootstock, and do your graft nearer to where will be the ground in the mature tree. Just do it low. You don't want to do it too high. Usually about 6 inches of rootstock stem is perfect. Don't go higher than that, and that should work out well. Rootstocks can be purchased from lots of different nurseries. We've bought them from Lawyers in Washington, Oregon, another nursery called Burnt Ridge. There's another one closer in the San Luis Obispo area as well. Here's a process called grafting over an existing orchard or tree, and you want to just change out the cultivar. You can do that through grafting. Replace the existing cultivar. Maybe a new, better one has come on the market, or you've just changed your mind. Adding a new pollinator that can be more effective with a new cultivar, or just trying something new. All of these graft types, I'm showing you some images here, and it's much better to be able to do these in person than it is to just show you images, but this is the best we can do. So I'm going to go through a few different types of grafts. The rind graft is done where the bark is slightly peeled away and the scion wood is inserted into the outer edge between the bark and the cambium, and then sealed with wax, something like that. So this is one called the rind graft, the rind being like the bark, and you can put new branches on there by grafting them in. There's also a method of grafting called double working, and that method is used as an interstock. So let's say you wanted to graft a scion wood, a really good fruit type, onto a rootstock, but they were not compatible. It's possible you can find an interstock, something that you'd put in between the two that's compatible with the scion wood and compatible with the rootstock, even though the rootstock and the scion wood aren't compatible with each other. That's called an interstock. Another method of grafting is called double working, and that's using an interstock to graft an incompatible scion to a rootstock. So you've got a rootstock and a scion, they're not compatible, but you can put something in between the two that is compatible with both to serve as that interstock. In this example, you're seeing there's a quince rootstock. Quince is an old world fruit type, and a Bartlett pear, something you want, but they're not compatible. And say you have a quince tree, you're done with the quince, you've bought your quince jelly at Trader Joe's enough times, you're sick of it. You cut it off and you want to graft a pear onto it, and those are not compatible. But the old home pear cultivar is compatible with both. You could graft that in between and create a successful new transformation of that tree from quince to Bartlett pear. There's also the side graft, which is similar to a rind graft. You're just doing it on one portion of the rootstock, and the rootstock can stay present, and you're just adding a branch on of a particular scion wood. It's not like you're cutting the whole rootstock off and transforming the whole plant, just adding a branch of something different to that tree. And for the more adventuresome is the approach graft. Let's say you have two plants and you want to graft them together. The plants are going to stay there. You're not cutting off the rootstock. You're just joining them kind of at the hip, low down, as you see in the diagram, and they graft together. So this is kind of fun if you want to do some creative kind of sculpting with plants, but it's also used as a form to save a plant. Let's say, look on the left on the image. If one of those was not doing well, dying, and it's really important to you, you could graft another one onto it, and then that approach graft takes, and after that, cut off the one that starts to die. So it actually saves it. It's kind of like adding a nutrient source to it to help it. And if it dies, then you have another tree that's already growing and continues to exist. And there's always cactus grafting. That can be done between lots of different columnar cacti, and even ones that form pads too. It's pretty easy with cacti, and they're not like a commercially, well, not a food source, but in nurseries they tend to be a fun oddity, and that's why they're done. People buy them because they're interesting and kind of cute. There's also a bud graft, which is taking one bud off of the scion wood and inserting it into the stalk in a little sleeve that you cut underneath the bark. You make that T-shaped incision and slip that bud behind there. That's a method that's used in rose propagation quite a bit, and some fruit trees. Then there's patch bud grafting, where it's similar to bud graft, but it's you take a lot more tissue of the bark from the scion wood and attach it to the rootstock. Bridge grafting is somewhat similar to approach grafting, but in this case, if you've got some kind of girdling or a lot of damage on your tree or shrub, you can take branches from scion wood or from a different cultivar or from the exact same one and use them to graft over that wound. So the nutrients and water and sugars can pass freely from the top of the plant over that wound to the bottom through those grafted on pieces. Here's an example of a bridge graft that was done from one branch to another just to increase the strength of that oblique angle. Those two stems, the two trunks are coming up, and they're so close together that water can get in there and kind of crack it and weaken those two. But this graft was done to almost like a cable or a metal plate that holds those two branches closer together through a graft. Inarching is a form of grafting that can be done too, where you would take small seedlings of that species or a closely related species, plant them around the base, and then graft them onto the existing bark over a wound. Here's a mature street tree in Victoria, Canada, and just a picture of a very dramatic graft. You can see the top part of the tree has a very different growth form than the bottom. The bottom is the rootstock, the top is the scion or was the scion, and where they join is very clear. Fruit trees in general have different kinds of temperature requirements, not all of them, but a lot of them. Grafted fruit trees, and almost all of our fruit trees that we buy at the store are grafted, and a lot of fruit trees in general are grafted because they've been bred for so long and we've tried to improve them. But a lot of them require chill hours, and that includes days or hours of 45 degrees and below. These days and hours do not have to be consecutive, but the days need to be consecutive. So there's plenty of trees like apple trees. They need chill hours. They like a cold snap. That's what induces their fruiting to really take off. But they need that chill before that happens. So they need a certain amount of chill hours, and we don't get a lot of cold days in Santa Barbara. So choose fruit trees that are called low chill. And when you see the label, if you didn't know, you'd say, oh, low chill fruit tree. It makes it sound like it needs low cold, low temperatures, real cold chills. But it means the opposite. They need less cold time to be able to fruit well. If you plant, if you don't get a low chill fruit tree, let's say an apple, and you lived in Santa Barbara, Ventura, San Luis Obispo, your tree is not going to produce that well. It doesn't get cold enough. But get a low chill one and it will do better. Where to put them can help too. You know, the north side of buildings where it's cooler and darker in the winter, maybe in a valley. Those are the spots on your property or on your farm, whatever your piece of land is, the lower spots, the valleys, and the north-facing slopes and sides of buildings are going to be cooler and darker, and because they don't get as much sun, they'll be colder, and that will help help improve the production. Some apple cultivars that are low chill, meaning they don't require as much cold, are Granny Smith, Gala, Golden Dorset, Anna, Fuji, Pink Lady, and a Honeycrisp cultivar that we have used a couple years in class is also low chill. Just check with the nursery wherever you buy them from, and they'll let you know what will work in your area.